Today we're graphing quadratic equations in standard form. This is where it's set up kind of like it's ready to go for the quadratic formula. You got ax squared plus bx plus c. It's all over there. So here are the steps. Feel free to pause if you want to write these down. Step one, we're going to find the axis of symmetry. That's the invisible line that perfectly splits the graph in half. So the way we're going to do that is with the equation x equals opposite of b over 2a. That's also going to be the x-coordinate of our vertex. So as soon as you find that x-coordinate of the vertex, you plug it back into the equation, solve for y, and that will be the y-coordinate of your vertex. Whoa! So find the vertex. You get a free point. If they have a c, a number without an x, that's your y-intercept. So you could plot that point as well. And then you're going to choose another x to substitute in, solve it for y, get a corresponding point, and then we're going to reflect those points across the axis of symmetry. Here are the steps. We breezed through them. It's going to be more applicable when we actually start doing the problems. Here we go. Y equals x squared minus 2x minus 3. Now this is factorable. You could get it into intercept form, but we're doing everything in standard form today. So first thing we're going to find is that axis of symmetry. I'm going to abbreviate it AOS. And we'll say x equals opposite of b over 2a. So if you look at the equation, the a would be a 1, right? There's a 1 in front. The b would be negative 2. So we're going to have negative 2 over 2 times 1. Negative 2 is opposite of negative 2. Positive 2. Denominator 2 times 1 is 2. 2 over 2 is 1. X equals 1. So again, this is the invisible line that divides the graph perfectly in half. I actually like to draw a dotted line, but again, in theory, it's invisible. Now, this is also the x-coordinate of our vertex, 1. So how do you find the y-coordinate? Well, you take this x, it says x equals 1, you put that back into the equation. So we're going to say y equals, and any time in the equation when I see an x, I'm putting a 1. So it'd be 1 squared minus 2 times 1 minus 3. We simplify this as much as we can and we'll have our y-coordinate. 1 squared is 1. Negative 2 times 1 is negative 2. So we have 1 minus 2 minus 3. You should go left to right. 1 minus 2 is negative 1. Minus 3 is negative 4. So the y-coordinate of our vertex is negative 4. We can go ahead and plot that point. 1, negative 4. 1, 2, 3, 4. There we go. We got our first point. Now, it also says on the last one, step 3 says c is the y-intercept. C is the only number without an x attached to it. That would be negative 3. So we could say the y-intercept is, and we could even label that as a coordinate, say it's 0, negative 3. So go ahead and plot 0, negative 3. Now we can always just reflect these points across the axis of symmetry. If you look, that point is 1 away from the axis of symmetry, so we could reflect it 1 the other direction, and we get a free point, and we don't even have to do any math for it. Now we do need to show some math for another point. If you look, we're picking any number to put in for x. I usually just pick the next 2 over. So if you look, we have it for 1, we have it for 0, so I would go the next one over there, negative 1, or go the other way. We have 0, 1, and 2, so let's go with 3. I like positive numbers, so I'm going to go with 3. I'm going to make some space here. So if we put in 3 for x, whatever we get out, that becomes the y-coordinate. So let's see, y equals 3 squared minus 2 times 3 minus 3. 3 squared is 9. Negative 2 times 3 is negative 6. 9 minus 6 is 3. Minus 3 is 0. So when we put in 3, we got out 0. So you can give yourself a coordinate at 3, 0. And then you can always reflect that to the other side of the axis of symmetry. If you look, that's 2 spaces away. It's 2 away from the axis of symmetry. So you can go 2 in the opposite direction and give yourself a free coordinate. That means if we were to put in negative 1, it's also going to come out to 0. But we don't have to do the math. That's the great thing about the reflections. Now we can turn this into our parabola. Yay! Now you could choose more than one point, and you also don't have to choose the x that's the next one over. The reason I usually do that is to make sure that it fits on the graph. Because if you were to pick like 10, let's see, 10 squared minus 2 times 10 minus 3. 10 squared is 100, minus 20 minus 3. This would give us 80 minus 3, 77. So you'd have a point at 1077, but obviously that's too huge for our graph. Our graph just goes 10 by 10. You could scale it differently, but I don't want to deal with that. Just pick the next two over. It'll be easier for you. Let's try another one. We got 2 more today. Negative x squared plus 4. Here's something I didn't even point out on the last one. But when a is positive, it's going to be a U-shaped graph. This a is negative 1. Out in front of the x squared is negative 1. That means it's going to be an upside down U. So that's something to always keep in your mind when you're graphing. If your a is positive and somehow your parabola is upside down, you did something goofy. So look back over your work. All right, again, first thing we're going to do is find the axis of symmetry, which is x equals the opposite of b over 2a. In this case, remember, b is just the normal x's. There aren't any x's here, so I would put in 0 for b. A is negative 1. Now, simplifying this, there's no such thing as negative 0, so it's still going to say 0 over negative 2, and 0 divided by anything is 0. So our axis of symmetry is right at 0. It's just the y-axis is our axis of symmetry on this one. And that 0 for our x is the x-coordinate of our vertex. To figure out the y, you plug it back in. So we have y equals negative 0 squared plus 4. Now 0 squared is 0. Again, there's no such thing as negative 0. It's just 0 plus 4. Man, I don't know what's going on with the board today. Is 4. So the y-coordinate of our vertex would be 4. So give yourself a vertex at 0, 4. Again, the a is negative, so this is going to be upside down. We don't get a free coordinate with the y-intercept because, look, we already have a point at 0, 4. So no free points on this one. So we're going to pick 2 numbers to put in for x and solve them out so we can get some corresponding y's. Again, I always just pick the next 2 over from the axis of symmetry. If we're at 0, I want to pick 1 and 2. Those are just going to be easiest for me. So let's see what happens when we pick 1. Now, here is a trick. If it's negative x squared, you have to square it first and then make it negative at the end. So 1 squared is 1, but then it's like opposite of that. So we'll have negative 1 plus 4, which is positive 3. So we put in 1, we got out 3. So our coordinate is going to be at 1, 3. Now if you look, let's just reflect it now. It's 1 away from the axis of symmetry, so just reflect it 1 on the opposite side. Boom! Free coordinate! Now we do need another coordinate, so we got 0, we got 1. I'm going to try 2. Two squared is 4, so it'd be negative 4 out in front, and negative 4 plus 4 is 0. So we put in 2. We got out 0. There's our point. 2, 0. That is 2 away from the axis of symmetry, so you could reflect it to the opposite way. And look, we've got our parabola. How cute is that? Yay! Remember, these are U-shaped graphs. They're not V's. So make sure you throw some curves on there. All right. 1 more. This is it. Oh my gosh! All right. Okay. Got to find the axis of symmetry. A, O, S, X equals opposite of B. B on this one is a 4 over 2A. A on this one is a 1. So up top we have negative 4. In the denominator we have 2, and negative 4 divided by 2 is negative 2. So our axis of symmetry which is also our x-coordinate of our vertex, is at -2. Once you find the x, plug it back in and solve for y. So y equals x squared, -2 squared, plus 4 times -2. -2 squared is 4. 4 times -2 is -8. 4 minus 8 is -4. So that would be the y-coordinate of our vertex. -2, -4. Now remember, we can get a free coordinate for the y-intercept. Y-intercept is equal to c. C is the number without any x's. Oh, there's a number back there. Goose egg, 0. So our y-intercept is going to be right at 0, 0. Free coordinate right there. Now, reflect it to the other side. It's 2 away from the axis of symmetry. Reflect it there. You can see how this graph is going to look, but we do need to show some work for another coordinate. We have it for -2 and 0. Let's get wild and go for -1. Let's see what happens when we plug in -1. Y equals -1 squared plus 4 times -1. Now here it's -1 in parentheses squared. When you square any number, it becomes positive, so that would be 1. 4 times -1 is -4. 1 minus 4 is -3. So we'd have a coordinate at -1, -3. Plot the coordinate. 1, 2, 3. It's 1 away from the axis of symmetry, so go ahead and reflect it to the other side. And then draw in your parabola. So much fun graphing parabolas. That's a lot of words. Hey, we're done for today. To be continued, we're going to practice again tomorrow.